Hey guys, Mr. Backerberg here. In this video, we're going to take a look at periodic functions. So when we're talking about periodic functions, a function is periodic if there is some positive c value such that f of t plus c is equal to f of t. So what that means is that function values are repeating themselves as we're looking at just some general t value versus this t plus c. So if we think about what's happening with our unit circle, if I look at my circle and I draw an angle out in standard position, so starting along that positive x-axis with the initial side, and then we rotate it up, and I'm just going to call that angle theta. And that's going to create some general x and y ordered pair as we're looking at where this angle is intercepting our circle. So we could say that the cosine of theta is equal to our x value, and the sine of theta is equal to our y value. But as we're looking at this angle, instead of just stopping when I hit this terminal side, if I made an extra rotation around and then went up to this terminal side, then that angle is definitely much bigger than that original theta that we looked at. But as we look at where this angle is intercepting our circle, it's the exact same x and y values. Now, we've looked at coterminal angles where we can find angles that start in the same place and end in the same place, but they're different sized angles. And one way we found coterminal angles was by adding on 2 pi. And that's because 2 pi is a full rotation when we're talking about radians. So this green angle that we're looking at in here would really be theta plus 2 pi, since we went an extra rotation all the way around. But again, it's got the same exact x and y value. So I could say that the cosine of theta plus 2 pi is equal to x as well, and the sine of theta plus 2 pi is still equal to that y value. And really, this is going to be true for any number of rotations that we make. Instead of just making one rotation, I could make 2 rotations and then go up to this terminal side. It'd be the exact same x and y value. I could make 3 rotations or 4 rotations. Any number of rotations that I make, as long as I'm stopping at this exact same terminal side, then my x's and y's are going to be the same. So then my cosine and sine values are going to be the same. So as we're looking at this value that we're adding, our c value is really that 2 pi. So what we can say is that if I take the cosine of theta plus any number of 2 pi rotations, so I'm going to call that 2 pi times n, then that's just going to equal the cosine of the original theta value. And the same thing is going to hold true for the sine. If I take the sine of theta plus any number of 2 pi rotations, then that's going to equal the same exact value as just the sine of theta. And it's because sine and cosine functions are periodic with a period of 2 pi. Now, tangents are a little bit different. So if I draw out an angle in standard position, again, starting along the positive x-axis and just rotating up, and I'm going to call that the angle theta, and that's going to give me some general x and y ordered pair. Now remember, for tangents, if I do the tangent of angle theta, I need to take my y value and divide it by my x value. Now tangents actually repeat themselves more often than sines and cosines do, because if I were to take this angle theta and instead of stopping at this terminal side, if I rotated around and stopped at an angle down in the 3rd quadrant, that gave me the ordered pair negative x, negative y. When I make that tangent fraction, and I'm going to call this angle, so if I take the tangent of angle beta, then that would be negative y over negative x. And because both of those are negative, then our answer is going to turn positive, so that would just be y over x. Now this extra distance that we're rotating in here actually ends up being just pi. So this beta value is really our original theta value plus pi. So what we can say about the tangent then is that tangent of theta plus any multiples of pi is going to equal just the tangent of theta, and because this value that we're adding on is pi, then we would say that the period of a tangent function is just pi. So let's see if we can use that to help us out a little bit. I want to look at the sine of 57,801 pi over 2. But that's going to be pretty difficult for me to calculate without a calculator. So what I'm actually going to do is look at splitting up this angle inside of my parentheses. So I can think about what's happening in here, and I'm going to take one of those pi over 2's and separate that from the rest of them. Now if I take one of the pi over 2's away, then on top of my other fraction, I'm going to have 57,800 pi over 2 left over. But that fraction's reducible. That's just going to turn into 28,900 pi. And what we should recognize is that 28,900 pi is really just a big multiple of 2 pi. So because this sine function is periodic, with 2 pi being the period, then we can really ignore that 28,900 pi and just focus on that pi over 2. So we can look at finding the sine of pi over 2. And if we think about a unit circle, and if we draw an angle in standard position, pi over 2 would be this angle in here. So pi over 2 actually corresponds with a right angle. Now on our unit circle, because this vertical distance is 1, because the radius of our circle is 1, that's the ordered pair 0, 1, and the sine is the y value. So this value, this answer, is just going to be 1. Now here we've changed up the example a little bit, but we're going to use the same idea to try to help us out. So we're looking at doing the cosine of 288.45 pi minus the cosine of 280.45 pi. Now if we look, these numbers are very similar to each other, but that first one has an extra 8 pi in there. So I can really think about splitting this up into the cosine of 280.45 pi plus 8 pi. Minus that cosine of 280.45 pi. Now notice both of these have that exact same 280.45 pi, but this first one has that extra plus 8 pi. Now remember, cosines are periodic with a period of 2 pi, so every 2 pi these repeat themselves. So it would repeat after 2 pi and after 4 pi and 6 pi and also after 8 pi. So really, because we've got extra 2 pi rotations in here, we can ignore those and just focus on this as being the cosine of 280.45 pi in the front. But then on the back end, we've also got the cosine of 280.45 pi. And here we're subtracting the exact same value from itself, so we should just end up getting 0 as our answer. Now for our last example, we're going to look at the tangent of pi over 4 plus 99,999 pi. But remember, tangent has a period of just pi as opposed to 2 pi, like we saw with the sine and the cosine. So this 99,999 pi on the end, that's just a really big multiple of pi. And because this tangent is periodic with that period of pi, then those extra pi values in there aren't really necessary. So we can just look at this as being the tangent of pi over 4. And the tangent of pi over 4 happens to be 1. That's going to be it for this video. Thanks for watching.